In this video we solve problem 7 of Unit 15. We have a solenoid, which we can draw like this, that has a length, total length of 80 centimeters. The radius, so the radius small r, is equal to 3 centimeters. And it is designed to produce a magnetic field of 0.19 Tesla. So this is what we wanted to produce in the center. The wire can carry up a current up to 10 amperes. So the maximum current is 10 ampere. So and they're asking us what is the minimum number of turns per unit length that the solenoid should have. So this is N. So we have been asking what is N. If you go back to the theory, you will see that the magnetic field in the center of a solenoid, it's given by mu sub 0 times the current times the number of turns per the unit length. Okay, so if we have a fixed magnetic field, in this case 0.19 Tesla, if we have an intensity of 10 amperes, we will need a certain number of turns per unit length. However, if we have less than that intensity maximum, we would need more number of turns per unit length. So if we put here the maximum, what we will get here is the minimum number of turns. Okay, so here we can say that the minimum number of turns is going to be the magnetic field divided by mu sub 0 times the maximum intensity it can carry. If you remember, mu sub 0 is 4 pi times 10 to the minus 7 Tesla meter divided by ampere. So if you do this calculation, this gives you 1.5 times 10 to the 4 meters to the minus 1. So if you have intense currents that are less than 10 amperes, you will need more number of turns per unit length to manage to have this magnetic field. So this is one of the things that we're asking. And the other is what longitude of wire we would need then. So if we have, let's call that L, small l, the longitude of wire. And the idea is that this longitude, what we're going to do with this big wire is turn it around to make the solenoid, okay? So each turn of the solenoid has a perimeter of 2 pi times r, where r is the radius, okay? Because each turn is like this, it's just like a circumference where this is r, okay? So if we need n turns, then the total length is going to be n times 2 pi r, okay? So we don't know n, but we can calculate it because n is going to be the number of turns per unit length times the total length, okay, big L. So all in all, small l is going to be small n times big L times 2 pi times r, okay? If you use everything in the international system and you do the calculations, this gives you an L of 2,280 meters, which is quite long.